Hi, everyone. Thanks for joining us today. This is a webinar or a tech talk on introducing EC2 Spot Blueprints, a template generator for frameworks like Kubernetes and Apache Spark. My name is Chad Schmutzer. I am a principal developer advocate for Amazon EC2, and really excited to be here with you today. We're going to jump into this. We will have moderators available to answer your questions throughout the session. So please don't be shy. Please put your questions into the chat room, and somebody will get back to you with an answer throughout the session. So let's get into this. So for our agenda, we have a few items we'll be going through. We'll talk about how AWS provides a compute platform for virtually every workload. We'll dig into that a little bit and understand what that means. And we'll talk about Amazon EC2 purchase options. And then we'll talk about the deep savings available to you by using Amazon EC2 Spot instances. And then we'll get into the meat of this, which is introducing Spot Blueprints, and we'll understand what Spot Blueprints are, how we can use them. And then we'll spend some time in a demo, because I think most of you would like to see Spot Blueprints in action, and it's really the important part of this tech talk, is getting you comfortable with Spot Blueprints and understanding how you can apply it in your environment. And then we'll wrap up with a quick conclusion. Okay, so like I said, if you have any questions, please put them in the chat room. We do have moderators available to answer your questions as we go through this. All right, so as I mentioned earlier, AWS provides a compute platform for virtually every workload. And what does that mean essentially? To understand this, let's take a quick trip back in time. 13 plus years ago, Amazon EC2 was a very simple place. We had a single instance type called the M1. Basically had a single size at launch, so one size to fit all, basically. Utility-based pricing, pay for what you use. Very simple. You turn the instance on, you run it, you shut it off, you stop paying for it, just like your lights. And finally, Amazon EC2 provided the ability to scale up or down quickly as you needed. And customers really enjoyed this platform, enjoyed this environment, and were able to adapt it for their use cases. And over time, Amazon AWS has developed into EC2 has developed into the broadest and deepest platform of choice. And so, what does that mean? As customers have come back and said, "Hey, EC2 is a great platform for us to use. Can we get instance types that are tuned to our specific workloads or use cases or things like this?" And so, again, over time, we've developed multiple categories to choose from. General purpose instance types, burstable, focused on compute or memory intensive workloads, or storage focused workloads that have high I/O, GPU, graphics intensive, et cetera, intensive, et cetera, along the lines here with different capabilities, lots of choices around processor types, processor clock speeds, memory footprint, types of storage on the individual instances. You can choose from accelerated computing options, and as well as networking speeds up to 100 gigabits per second. And then we even offer bare metal instance types, and a wide range of sizes from nano to 32 extra large. And then if you combine these with additional options such as elastic block storage, Amazon EBS, and elastic inference, and the fabric adapters, there's lots of options to choose from. So over time, this has developed into 400 plus instance types for virtually every workload and business need. And so, what does this mean? It means we have a lot of capacity available to you to use for your environment and for your workloads. And this is leading into what we'll talk about here, which are spot instances, but our spare capacity. So we want to understand why we have so much spare capacity. It's because we have such a broad platform of choice. We have we have a lot of capacity available for you to use based on this wide range of choice for your workloads. And so this leads us to different ways to purchase that broad platform. And so over time, Amazon EC2 has developed multiple purchase options for you to choose from to find the right fit for your particular workload. So let's walk through these here for a moment. You have the option to choose on-demand instances as your purchase option, which means you pay for compute capacity by the second with no long-term commitments. And this is great for your spiky workloads that you're still defining your long-term needs for, your experimental workloads, et cetera, et cetera. As you figure out what your long-term needs are for your EC2 platform, you can lock into savings plans. Savings plans provide a discount for commitments for 1 or 3 year periods of time around your compute spend. This is great, provides a ton of flexibility for you, and it's a great way for you to lock in savings off of the on-demand price. Now, third purchasing option is something called spot instances. This is where you can get access to our spare capacity for savings up to 90% off of the on-demand price. So if you think back to that broad compute platform that we offer, you understand we have a tremendous amount of available capacity for you. And when that capacity isn't being used and it's available as spare, you can tap into it through a purchase option called spot instances. So you want to think flexible and you want to focus on savings plans and spot instances to optimize your overall performance and cost for your EC2 compute platform. The outer purchase options, actually launch capacity. So if you launch an on-demand instance or a spot instance, you will actually be launching an EC2 instance, right? So I want to make sure that that's clear, that those are both purchasing options and launching options at the same time. Savings plans are not launching options. Savings plans apply to discounts off of your on-demand launches. So just sort of setting the table here to understand how our purchase options and our savings plans work together to provide you with lots of flexibility around optimizing your performance and cost. So let's talk about spot instances, because that is at the heart of this tech talk and really what we want to focus on. So spot instances, again, as I said, are spare capacity from the same infrastructure, right? So when you purchase a spot instance, you're simply purchasing an EC2 instance, and it's the same capacity that you'd be purchasing if you launch it as on demand. You're just paying for it differently. You're paying for it with spot prices instead of on-demand prices. So spot prices are smooth, infrequently changing, and are based on basically overall long-term trends in our supply and demand. So as we have larger amounts of spare capacity or less utilized spare capacity, that affects the long-term price. And spot prices are based on that. And so spot is great to use for all kinds of different workloads. You can pick from every instance type we have available, essentially, and you can pick launch spot instances across multiple availability zones and attach them to put them into auto scaling groups and things like this. So lots of different options and components to pick from there. And the one thing about spot instances is that when AWS needs the capacity back, we can take that capacity back from you. We give you an interruption notice, and that interruption notice comes in the form of a 2-minute interruption notice. And we want to talk about how we can utilize that to benefit our particular workloads, and to understand, hey, if we have a workload running on a spot instance, we can get that interruption notice, and we can take action and do something with that. And we have lots of tools to help you work with that interruption notice. Spot instances have also been integrated in many other AWS services, partner offerings, and open source software. We do have a public roadmap for our EC2 Spot instances integrations. So if you'd like a piece of open source software to better take advantage of spot instances, please check out the public roadmap here. The link's at the bottom, and please feel free to open an issue and communicate directly with us around anything you'd like us to work on. All right, so spot fundamentals. Let's talk about this. Again, I mentioned spot instances are an interruptible instance type and must be returned when EC2 needs the capacity back. Purchasing option, I should say. So you want to take this into consideration when you're running your workloads. You need to understand that your spot instances will be interrupted based on capacity trends. And the location and amount of spare capacity available at any given moment is dynamic and continually changes in real time. So you want to make sure you understand that you're looking in multiple places for spare capacity for a particular workload, and we just want to make sure that you've set up your environment to take advantage of finding that spare capacity to power your particular workloads. So you do want to, again, think about this. Is your workload suitable to run on Spot, right? Is your workload interruption tolerant? And is your workload instance type flexible or time flexible? Because, right, the reason for this is that because our spare capacity is changing in real time, you will have interruptions. You want to make sure that you can handle interruptions. And you want to make sure that if you'd like your workload to continue running, you want to make sure that you can look for a Spot instance in a different location. That could be a different instance type, availability zone, or a different region, or you simply want to pause your workload until the spare capacity becomes available again. So these are all things you want to think about. Is your workload suitable to run on Spot instances? So I mentioned you do need to be flexible when running on Spot instances, and the reason for this is that each instance family, each instance size, each availability zone in every region is a separate pool of capacity, and we call those spot pools because when you launch a Spot instance, you want to think about launching into or potentially launching into as many of these capacity pools, these spot pools as possible, or at least allowing your workload to launch into as many of them as possible, because the amount of spare capacity in each of these pools is going to be fluctuating and changing in real time. And that also means that each pool has separate pricing associated with it, depending on the long-term trends in supply and demand for those particular pools. So I've just taken an example C4 instance here, and in one of our regions, let's say it has 3 availability zones, 1A, 1B, and C, and we've got multiple sizes that the C4 comes in. You want to understand that each of these again is a separate pool of capacity, and these are independent of each other. And so you want to say, hey, I can run a C4 extra large in all 3 availability zones, and I can also use 2 extra larges. And so that's going to give you access to 6 different pools of capacity just in that single region right there. So you want to think about this from a usability perspective. So let's touch on Spot best practices and what this means. So you only want to run workloads that are truly interruption tolerant, right? So meaning interruptions at both the individual instance level and the overall application level. Your workloads do need to be flexible, right? Meaning they can be shifted in real time to where the spare capacity currently is, or otherwise paused until that spare capacity is available again. And in practice, being flexible means qualifying a workload to run on multiple EC2 instance types. You want to think big here, multiple families, sizes, and generations, and in multiple availability zones at any given time, right? So this is important to think about, and it's critical to your success when it comes to using Spot instances. So again, Spot instances are interruptible, and so this means if your workload should take advantage of some sort of interruption handling, think about how you'll do that. Does that mean when an interruption at a Spot instance occurs, do you need to do some load balancer connection draining? You want to drain your connections gracefully off of an instance that is going to be interrupted. Do you want to do automatic job retries? If an instance is going to be interrupted and a job in your batch workload, for example, is running on it, do you want to interrupt that gracefully? Do a job retry on another instance to make sure that job can run somewhere else. If you're running containers on Spot, which is a very natural fit and a very popular thing to do, perhaps you want to drain your containers off of any Spot instances that are going to be interrupted, and then reschedule those containers on other instances within your environment. So you do want to think about performing graceful interruption handling if this is something that is important to your workload. Many customers simply just have this logic built into their workload automatically, and so they don't have to think too much about interruption handling. But some customers do want to have a bit more interruption handling built into what their workloads are working on. So over time, we've worked very hard to improve the ease of use of using Spot instances, right? So we want to make them as easy to use. We want them to be as available to you as possible, and we want you to be able to find that spare capacity. So we've released features over time, such as the recently released EC2 instance rebalance recommendation. This is a new signal that we're providing that gives you a heads up when a spot instance is at an elevated risk of interruption. So this is something that you can tap into to understand, hey, one of my instances is at an elevated risk of interruption. Maybe I want to start checkpointing my job. Maybe I want to start draining my containers. Maybe I want to take some sort of action against this interruption, this elevated risk of interruption signal. We also released something called the mixed instances policy. This is something that applies to autoscaling groups, and it allows you to tap into multiple instance types and purchase options across multiple availability zones in a single autoscaling group. And it's really a key component to taking advantage of spot instances. For adding on to that, we have a capacity rebalancing, which is a new feature for autoscaling that proactively manages the spot instance lifecycle in an autoscaling group. And so capacity rebalancing can essentially take action when spot instances in an autoscaling group are at an elevated risk of interruption by proactively launching replacement capacity, so that when a particular instance is interrupted, you've already got a head start launching a new instance to replace it, another spot instance to replace it. And so it's a very, very cool feature to check out, to take advantage of. And finally, we have allocation strategies that help find the most optimal spare capacity. And one of these allocation strategies is called the capacity optimized allocation strategy. And this is an allocation strategy that you can apply to your autoscaling group to say, hey, please find the spot capacity that best fits my workload and is the most optimal spare capacity that you have at the current time. So these are all features that we've launched to help make Spot easier to use, and really they're for you to take advantage of using Spot in your environment. And finally, we have an Amazon EC2 instance selector. It's a public open source CLI tool and Go library that helps recommend instance types based on resource criteria like number of vCPUs or amount of memory that you need. And so this tool can help you with your instance flexibility that we talked about earlier when it comes to taking advantage of Spot instances and being flexible as a best practice. All right, so Amazon EC2 Spot integrations. Spot is a very popular purchasing option, and it's been integrated into many different platforms, both AWS services as well as third-party partner services. And so, customers really like to use Spot within each of these services, and they can tap into the deep discounts that Spot offers on our EC2 platform to help power these different types of workloads and environments as they'd like in their particular use case. And so, as you can see, there's a pretty significant list of integrations here, and we're working hard at this. And if there are other integrations that you'd like to see, we'd love to hear about that from you. So, at the end of the day, when customers hear about Spot and they see all these integrations, they typically want to get started quickly, right? They can't wait to get started, and they're anxious to go. All right, ready to use Spot, sounds great. How do I do it? And so, we can give documentation, we can give blog posts, we can give tech talks as the one I'm giving, and it still makes customers, look around a bit to consume it all, right? To consume the documentation, to consume the blog post, and that takes up some time, right? That's development cycles that you maybe don't have at the moment, or spare cycles that you just don't have today to dig into all of this and to understand. Like customers want to get started quickly, they want to learn, and they want to move fast. And they say, what's the fastest way for me to get started? Like, and at the same time, I want to feel confident that best practices have been applied. And so, we thought about this, and finally asked, hey, what could we give you that would really jumpstart and get you going quickly? And the overwhelming response was, hey, if we could see workload templates or configuration templates that are presented as infrastructure as code in either AWS CloudFormation or HashiCorp Terraform, that would be the best way to get started, because this gives me the code, this gives me what I need to, as a good example. I can learn from it, I can dissect it, and this is the way that would jumpstart me the quickest. And so this takes us to Spot Blueprints. And so Spot Blueprints um, is infrastructure as code is a infrastructure as code template generator that lives directly in the EC2 Spot console, right? We wanted to give answer your request, give this to you right in the console, and help you get started quickly. Spot Blueprints basically guides you through a few short steps designed to gather your workload requirements while explaining and configuring Spot best practices along the way, right? So again, the idea here is help you get started quickly, but help you understand that all of these best practices that we just talked about earlier in this session are being applied to your particular workload, and at the same time giving you actual code and templates that you can use immediately. And so unlike traditional wizards, Spot Blueprints generates custom infrastructure as code in real time within each step, so you can easily understand the details of the configuration. And this is really important because this is sort of the anti-wizard. It's not hiding what it's doing from you. It's actually showing exactly what it's doing for you throughout each step in the form of infrastructure as code. And so we'll walk through this here in a moment. But the takeaway here is that Spot Blueprints helps you enable best practices easily without having to read multiple documentation links, multiple blog posts, watching multiple tech talks. The idea is for you to get started quickly and build confidence. So it even does things like asking about your EC2 instance requirements in the sense of helping you build agnostic workloads to help you get away from being tied to an individual instance type and thinking about being flexible across multiple instance types. And so it gathers your requirements in the form of vCPU and memory requirements instead of specific instance types. And so this is a helps you express what you need from a compute perspective in a much easier fashion. It then takes those requirements and then it builds a flexible list of EC2 instance types that are available in that particular AWS region where you're operating. And so, again, don't have to think about, is this instance available here, or do I have to take this into consideration? It's just going to give you a list of instance types that work for that particular region. It also helps apply high-level Spot best practices like availability zone flexibility to your workload compute requirements automatically built in. And so we'll see this as an example as we go through Spot Blueprints here in a moment. It also provides Spot best practices at the workload level, workload specific level as it goes. So, for example, if a particular workload, let's say you have a load balancer, a web tier with a load balancer, and you want to have graceful interruption handling built into that. Blueprints has a template that it can generate that'll help enable connection draining for you automatically at the load balancer level. Same thing for batch with batch automatic job retries, or with EKS in the sense of container rescheduling. So it's helping to enable these best practices in the get-go through the blueprint itself. So another awesome feature for Blueprints is that it helps you keep up with the latest features, right? So sometimes AWS puts features out at a pretty fast pace, and it's something that we love to give you as you ask for more features. We want to churn out more features quickly, but we can understand that sometimes it's hard to keep up with these latest features. And so Spot Blueprints is continually designed to be updated to take advantage of these latest features as they are released. So for example, I mentioned a couple of those earlier, like the capacity optimized allocation strategy and the capacity rebalancing for EC2 autoscaling. These new features are being enabled through Spot Blueprints so that you can simply go back and create a blueprint, and you know that you can feel confident that these latest features that we've put out are being utilized in the blueprints for you to tap into. So it's something. I like to think of it as an easy way to keep up with the latest features without trying to watch every single what's new post or read every new blog post that comes out. which is a very difficult thing to do sometimes. So again, I said Spot Blueprints is continually updated to support new features as they become available. And if we look back at those integrations, Spot Blueprints supports generating infrastructure as code workload templates for some of our most popular services used with Spot, right? So that could be Amazon EC2 Autoscaling, Amazon EMR, AWS Batch, and Amazon EKS. And we'll walk through each of these here in a moment. So we do have a blueprint for Amazon EKS using Spot instances with Amazon EKS. This helps you take advantage of the steep savings that Spot instances provide for your interruption-tolerant containerized applications. It takes advantage of EKS managed node groups with Spot instances, and this really significantly reduces the operational effort compared to self-managing your environment. In addition to launching Spot instances and managed node groups, this also helps you specify multiple instance types in your EKS managed node group. So lots of Spot best practices being rolled into this environment, and this is all available as a Spot blueprint, as we'll see here in a moment. Amazon EMR, right? So for those of you running big data workloads, Spark-based workloads that run on top of EMR, we do have a blueprint that helps you get started quickly applying all of those Spot best practices on top of Amazon EMR and Spot together. So, for all the things that you can configure inside of an EMR cluster, an EMR environment, blueprints can help you make sure that all of those checkboxes are checked off in terms of applying best practices, enabling capacity optimized allocation strategy, using multiple instance types per task instance fleet, and just setting things up in a way that you're confident that you can get started quickly with using Spot instances. AWS Batch, which is a fully managed batch processing service from AWS. It has some fantastic abilities to use Spot instances, has built-in support for EC2 autoscaling and Spot instances. It has built-in support for allocation strategies. It helps you with cost-optimized resource provisioning. At the end of the day, Batch and Spot are a great fit, just like the others are, and we have a blueprint that will help you just get all of this set up quickly and allow you to get going in a very short period of time. EC2 autoscaling, right? So EC2 autoscaling is a very, very powerful provisioning API. It provisions EC2 capacity, it maintains it, it can scale it, it can do all kinds of things. And so as you can see, I've got a sample autoscaling configuration here. And if we just kind of look through all of the different configs, there's some stuff to think about here. And so Spot Blueprints has thought about this for you automatically. So Spot Blueprints has a blueprint for autoscaling based workloads. And if you look at the actual configuration that it provides, you can see that it helps follow Spot best practices at an autoscaling config level as well. And so you want to take advantage of blueprints to help you configure an optimized environment with best practices in place, and then you can go back and look to say, oh, this is how Blueprint set it up, and this is a great way for me to think about this in my environment, and an easy way to get started. So let me talk here about a customer, Snocco, who took advantage. Snocco Technologies took advantage of Spot Blueprints to help fast track their deployment. So they were interested in using EKS for their Kubernetes-based workload, and so they took advantage of the Spot blueprint for EKS managed node groups with Spot. They were able to fast track their deployment. They were able to implement Spot on EKS with ease, and ultimately have seen an overall compute cost reduction by 70%. And so I think it's a great use case, a great example of a customer helping to fast track their Spot deployment with best practices in place, with using containers, container framework, and just to really move quickly and get those savings enabled quickly, because it really, at the end of the day, that's what this is all about, is locking in those savings as quickly as possible and helping you save money and scale on the cloud. All right, so I've spent some time talking here, and so now let's just get into a demo. I really want you to see Spot Blueprints in action and understand how it can work for you. So let me flip over to my browser. So as I mentioned, Spot Blueprints is in the Spot console. So let's find the Spot console. If we're at the primary AWS page in the management console, we can head over to EC2. And within EC2, on the left-hand side under instances, we have our Spot requests. So once we head to Spot requests, we have, if I had any Spot instances open, I would see those Spot instance requests in this console here. But I've cleaned things up so that I can do a live demo for you here, and you can check this out and watch how things work. So Spot Blueprints is located right here in the upper right-hand corner of the Spot console, right? So Spot Blueprints is here. So you simply click on Spot Blueprints, and from here you're taken to the first page, which is a list of available blueprints that we have made. And I've went over batch, EC2 autoscaling, EMR, and EKS. And so these are very, very popular frameworks that customers use with Spot traditionally. And if there's something here that you would like to see, if there's a blueprint that you would like us to build, we have a link here on the very first page, which is don't see a blueprint you need. Simply click on this and it'll take you to a form to let you fill out. And I promise you somebody is reading these. We look forward to receiving these, and we want to hear what blueprints we should build next for you. So please, please fill this out and submit it to us. We would love that. So let's walk through one of these blueprints here. So let's start with EMR. If I select the EMR blueprint, it gives me some details around what's going to what this blueprint is going to provide for us. And so we can see it's going to help us set up basically the full stack, everything from the VPC configuration if we'd like it to, all the way up to the EMR cluster, all the way to the required dependencies, including roles, network, managed scaling policies, everything that you need to quickly get started with using EMR and Spot. If you don't even want to take go through the few steps needed to configure the blueprint, you don't even have to. You can just simply download a pre-configured blueprint that uses default Spot and EMR settings right here. And these can be downloaded as either CloudFormation or Terraform. So I can simply hit this download button, and I've already got an entire CloudFormation template ready to go, right? So, and this has best practices enabled. It's just it's just ready to go. I mean, you could simply take this and launch it, and it has already set up a flexible list of instance types for you to use. Now, the thing is, these instance types aren't tuned to your particular workload requirements, and so if we want to walk through the wizard, we can do that. So let's head back here and understand what this means for us. So let's go ahead and click on EMR and click on Configure Blueprint. Right. So first thing we'll need to do is configure our permissions. So as we go through the blueprint wizard here, we can see we want to give our blueprint a name. We'll call this Tech Talk EMR. And so I've named my blueprint, and on the right-hand side, we can see that as we go through each of these steps, we have some explanation of what's happening at each step, and we also have links to learn more. If you do want to understand more about IAM roles, for example, with EMR, you can find links here that are relevant to this particular section. So in permissions, if I have existing roles in my account that I would like to use for EMR, I can use them, and I can select which role I would like to use here. Or if I want to let the blueprint configure a new role, I can simply let the default sit for create new role, and we'll do that here because perhaps yourself as a new customer haven't set this up yet. This is a great way for you to make sure that everything is configured in line with your particular blueprint. Same thing with your instance role. You can use existing roles if you have them in your account. I could simply select them, and these would be included in my blueprint, or I can allow the blueprint to create a new role for me. All right. So here at the bottom, this is showing me if I were to deploy this, the code from this step will create or use the following 3 resources: 1 instance profile and 2 roles. So I can see what's going to be happening here based on what I've selected, and I can get access to the actual code snippet preview for CloudFormation or Terraform for what will this particular configuration step will be creating in my overall blueprint template. So I've got the code right here. I can view it. I have full transparency into what this blueprint is configuring for me. And again, if I had selected an existing role in my environment, let's just pick one here, and I'll put it back here in a second. Do I have an EMR role? Let's see. Let's grab that one. I'm just selecting one as an example, but we can see here that now this is actually referencing a role that exists in my environment already. So again, this blueprint code is reflecting in real time what I've configured up above. So let's head on to our next step here. Okay, so here's the networking section, right? So for our VPC, I can either use an existing VPC. Maybe I've got a VPC where I like to deploy my resources, but maybe I don't. Maybe I want to start fresh with a new VPC. Either way, this blueprint will help me ensure that best practices from an availability zone perspective are in place. So we can see this warning here: spot best practices are not followed because I did not select a VPC and tell it to use all availability zones in my VPC, right? So if I were to remove one of these, I can see that spot best practices are not being followed because I did not allow the VPC to tap into all available availability zones within my VPC. So this is helping me enforce that spot best practices are in play here from a blueprint perspective. So I actually will just tell the blueprint to go and create a new VPC for me automatically and enable all subnets for me automatically as well. So we can see in this section, I've got a shiny new VPC with Internet Gateway, VPC gateway attachment, routes, routing tables, table associations, all the code necessary to set up a VPC with spot best practices in place configured for me, and I've got access to the code right here. Same thing with Terraform. If I'm a Terraform shop, I can grab this and understand what's happening here. So, and again, best practices are explained here on the right, and we have links to more information as necessary if you'd like to learn more. So let's click on next and head to the next section. Now we are in configure our compute environment. So here's where things get really fun. Here's where I can specify my workload requirements based on my my overall compute needs, right? So here I can specify what I like to define my capacity units as virtual CPUs, as instances, or as memory. It's totally up to me. I like to choose vCPUs, but you can also utilize instances or memory if you're memory bound. And many EMR customers, for example, for Spark workloads, are memory bound. And so I can define my overall needs in memory, vCPUs, or instances. Well, let's do vCPUs in this case. So let's say that my core nodes for my EMR cluster each need 2 vCPUs, and actually let's say 2 and 2 here, but I can increase these as necessary. But we can simply allow this page to take in an ARM inputs and then apply best practices based on the fact that it's going to take the list, the specs that I've defined here in terms of my desired capacity, and interpret these as a list of instance types, a flexible list of instance types that it's capable of using. Now here, at the individual instance configuration, I can also define minimum number of vCPUs per instance and the compute ratio, vCPU to memory compute ratio. And so in this case, for example, let's say I wanted to have 1 vCPU per 4 gigabytes of memory because I want to have a higher ratio of memory to CPU. I can define that here, and the list of instance types that it is selecting for me is reflecting my actual requirements here, right? So we can see that the core node list and the task node list instance types are all filtered by the configurations that I've specified up here. Okay, so again, we can look at our code snippet. We can see that I have my my CloudFormation and my Terraform templates here that are building. We can see that it's configuring everything for me, the entire virtual private cloud, the permissions, and now it's adding in the EMR cluster as well. And so it's including all of the configurations that I specified up here. If I wanted to increase the amount of CPUs in my task nodes, for example, I can do that here. And in the template below, we can see that this is going to be reflecting the overall amount of capacity. See that how that changed to 16. So this is basically updating the template based on my parameters above. So again, I'm going to be deploying one EMR cluster and one instance fleet config based on what I've just specified above, and we can click next and move forward. All right, so another best practice with EMR, you can potentially turn on EMR managed scaling. So this is um, an optional configuration, but if you do turn this one on, the EMR cluster will actually scale up and scale down based on the amount of resources that that are necessary to compute a particular job or step in my EMR cluster. And so I can turn this on, and it will be enabled with min and max capacities as I've defined, and it will be enabled in my blueprint as well. So at this point, I've walked through the 4 steps for configuring my blueprint. I can see the code and what it's going to do for each section, and I can head on to click next, and I'm taken to the page where I can grab the full blueprint code, right? And so this code is available to me again in either CloudFormation or Terraform, right? So this is the full blueprint template. So all those little code snippets that we saw as we went through each wizard are all combined to provide a single blueprint that will launch our environment for us, and we can download these. So I can simply download this Terraform template. I've got it here. I can open it up, and we can see that. Well, I can open it in Sublime. Grab this real quick. We can see our Terraform code right here that's ready for us to use. And so, all right, we've got all the spot best practices built in here for us to utilize with multiple instance types selected, allocation strategies enabled. Everything that we would want to do by hand has been done for us automatically through the blueprint. So let's take a look. We can also get a list of instance configuration, a nice summary here of our instance configs, and to see that all of our spot best practices have been applied. And we can also get a resource summary of what will be enabled through the stack if we were to launch it. So from here, again, I can download the template. I can then save it, and I can change it if I want to configure something even further. You know, I can grab this CloudFormation template, for example. I can download it, and I can tweak it for my environment even more if I wanted to. If there's something that I couldn't configure in the blueprint that I want to tweak, you know, I've got the code now, and this can then be adapted to your environment even further if necessary. You know, whatever works for you. But the idea here is that you now have the entire code available for you. So I can take this from here and actually go to deploy in CloudFormation. And if I do this, Blueprints is going to do a nice thing. It's going to stash my template, my blueprint template into an S3 bucket, and then take me over to the CloudFormation console so that I can then actually launch this stack here. And so it's pretty handy because I can just do this directly from the CloudFormation console without even having to leave the console. or I can launch it from. I can also launch it from maybe the CLI if I wanted to. So let's just launch it from here. I can just simply copy in the URL for this template. I can give this template a name. We'll call it Tech Talk EMR. We don't need to set anything special here because everything has been configured in the blueprint already. I can acknowledge that I will be creating IAM resources, and I can click on Create Stack. And at this point, I've kicked off a brand new blueprint launch that is going to have all of the resources that I need to power an EMR cluster that is powered by EC2 Spot instances with best practices in place configured. And so this will take a few minutes, but we can walk through this and watch as each of these resources are being created for us. So while that's happening, so let me flip back over to the Spot Blueprints console. Let me just take you through, walk you through the other blueprints here real quick. I won't go through all of them in as much detail, but we just want to see that for our containerized frameworks, for Kubernetes frameworks, we can go through a similar environment. We can configure the steps that are needed to configure an EKS managed node group with Spot being used, and I can walk through this, and I can also get a very similar template. Let's see, we'll call this Tech Talk EKS. I can simply say, hey, let's create new roles for each of these environments. Let's check out the code. I can walk through this. I can let it create a new VPC with multiple subnets for me to enable Spot best practices, or I can use an existing VPC. I can name my cluster here, and I can give it some my EKS Spot cluster. I can give it node group configuration with min, max, and desired capacity, and I can define my Spot configuration with Spot best practices in place as well. And we can see that it's going to give me a healthy list of node group instance types so that Spot best practices are configured and in place for my EKS cluster. So again, I've got my code snippet available to me. We can see that each section is being configured. And finally, after just a few short steps, I've got an entire Kubernetes powered blueprint ready to go here using managed EKS node groups. I've got an entire VPC configured. I've got all of the Spot best practices in place. We have capacity rebalancing enabled through this managed node Spot managed node group here. And so again, I can go into this confident that I've learned how to apply Spot best practices to an environment like this, and I can understand. I can grab this template and I can simply utilize it in my environment as I would like. So in taking advantage of either Terraform or CloudFormation. Okay, so let's jump back over here to our EMR stack. We can see that EMR, this blueprint is being launched. Again, all of the resources that I need are being launched right now. The EMR cluster is launching, and I could even go to, in fact, let's do that here in our console. We can see that our Tech Talk EMR cluster is in the starting state, and it's currently provisioning the components of our EMR cluster that are needed, and we can see that, let's see what we can see here, cluster details. We can see that we are using Spot instances for the overall configuration, just like we've asked for, and we have our scaling policy enabled with core and task units defined. We have our allocation strategy defined, and so again, I'm confident and I'm ready to go in terms of using Spot with my EMR environment, and it has even installed and configured Spark for me to use as well. So it's the idea here is that we want to get you started quickly and confident. There's your application Spark installed on your EMR cluster. Want to get you started quickly and confidently using Spot with your favorite framework, and get you going quickly. All right, so we still have the Tech Talk launch in progress. So I think you can understand what's happening here. So let's head back to to our presentation. All right, so in conclusion, Spot Blueprints are designed to quickly explain and generate templates with Spot best practices for each workload. The custom generated workload templates can be downloaded in either CloudFormation or Terraform format, allowing you to further customize and learn before deploying in your environment, right? So these are examples that you can download, and then you can tweak them and further customize them as you need for your particular environment, and to help you get started quickly. We'd really like to hear what blueprint you would like to see next. Please head to the Spot Blueprints console. Please click that button that says tell us what blueprint you'd like us to build. We are extremely excited to hear from you, and we really want to hear about all the great things you've done by using Spot Blueprints. So thank you so much for spending the time today. Thanks so much to our moderators for helping answer your questions throughout this Tech Talk. If you'd like to learn more, here's a link to a blog post on Spot Blueprints where you can learn more about it. Gives you another sort of similar walkthrough that we just did here. And that final link there is taking you to the Spot Blueprints console to help you get started quickly. So again, thank you so much for spending this time with us today. We really enjoyed this. Hope you have a wonderful day and hope you can take advantage of Spot Blueprints soon. Thanks. Take care. Bye-bye.